my name is Irene, and in this video we're going to talk about solid tools versus intersecting faces and how we can use both set of tools to allow us to create complex geometry. So let's get to it. So before we begin, the first thing that we need to do is define what is solid geometry, because solid tools work on solid geometry only. So in order to do that, I'm just going to draw a little rectangle here, and I'm going to push pull it. So now we have a box, okay? So first thing first, solid geometry are groups and components only. Raw geometry cannot be solid. So in order to understand what solid geometry is, we need to convert this box into a group or component. So I'm going to select this guy, and I'm going to make it into a group. So how do you know if something is a solid geometry? Super simple. You're just going to go to your entity info. And again, if you do not see your entity info tab on your default tray, you're going to go window, default tray, and it's going to be one of the first ones. So the quick way to determine if a group or component is a solid geometry is by reading its entity info. If it's a solid, it's going to tell you that it's a solid group. If it's a solid component, so I'm going to go click, 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 right click component. If it's a solid component, it's going to tell you that it is a solid component. But if it's raw geometry, you're going to see that it's just 18 entities. It's just 18 things. So very, very important. It has to be a group or a component in order for the geometry to be solid. And now, what does make a group or component solid? Now, this one is a little bit hard to define, like in words that I can explain. So if anyone has better words to explain this one, by all means, feel free to leave them in the comments. I'm always open to be educated by people who know more than me. But basically, the idea is that a solid geometry has to be a group of lines or faces that have no extra or missing parts. So for example, if we're working with a box, there should be no extra bits and bobs, or there should be no missing lines or faces. So check it out. I'm gonna come here and I'm gonna copy this box twice. And what I'm gonna do is I'm gonna show you how quickly and easily a geometry can break from a solid into a non-solid geometry. So again, we're starting and all three of them are solid. So let's say that, for example, on this group, I'm gonna get rid of one of the faces. Well, by doing that, it is no longer a solid. It is now just a group. Same thing. If I come here and there's just like a little extra line of nothing, this guy is no longer a solid. It's a group. So now you can probably go back all the way to when I was explaining how to draw lines and faces and how to make walls and why I was such a psycho about clean geometry. And I was like, no, you have to get rid of the lines. It has to be just like the faces. It's because of this. If your geometry has any missing lines and faces, any extra lines and faces, Sketchup will not consider it solid, and then you're not going to be able to use solid tools with it. Now, this is not the end of the world, but in my personal opinion, I find that it is easier to work with solid geometry in SketchUp, so I try as much as possible to make sure that my geometry is solid. One more thing that I want to mention about the definition of solid geometry is that solid geometry is going to be groups and components that contain raw geometry only. So it's not just that there can be no missing lines or faces or extra lines and faces, but within the group or component, there can only be raw geometry. So for example, if I go, I'm going to make one more copy of this guy. And if I go in here and let's say I have another group or component within this geometry, let's say that I'm going to make this guy into a group. Even though the geometry is enclosed, it doesn't have any extra or missing pieces, it's still going to read it just as a group because there is some extra stuff. Okay, so with that understanding of what solid geometry is, now we can start working with solid tools. So the reason that solid tools exist is because it allows us to make complex edits to existing 3D geometry. So in order to use our solid tools, I'm going to create a little companion for this guy. And just to make things more interesting, and so it kind of like clicks in your head why solid tools are cool, I'm going to make a sphere. And if you don't know how to make a sphere, the secret is that it's the follow me tool with two circles. The only thing that matters is that the circles have to be in different axes. So one of your circles is going to be your profile, one of the circles is going to be your path. You select follow me, click, and bam, you have a sphere. Now, if I try to make this sphere into a group or component, it's not going to let me, and that is because the sphere is a single face. In order to create groups or components, you have to select at least two things, and a single face is just a single entity. So if you want to turn the sphere into a group or component, which we do want to because we need it to be a solid, and remember, solids can only be groups or components, I need to go and undo, and I'm going to select both the line and the sphere, and I'm going to make that into a group. Once I've done that, I can cheat by getting rid of this line here, and when I come back, now this is a solid group. So I'm going to make my two objects crash. I'm going to bring this guy up a little bit just so we can see a little bit better. And there we go. We are ready to rumble. So the idea here is that if I would want these two guys to interact with each other, I can't. Because remember, the whole point of creating groups or components is to isolate geometry. It's non-interaction between objects. But there are cases where you want to have things that are separate groups or components, but you still want them to interact with each other. Imagine, for example, that this is, I don't know, this is like a stone vessel that is supposed to be nested within like a wood pedestal or base. So basically you would want to carve the wood to have the shape of the sphere. But here I cannot do that because again, they don't recognize each other. So this is where we're going to use our solid tools. So first of all, where are our solid tools? Well, they are modification commands. So you're going to be able to find them under tools, and they are these guys over here. Or to make your life easier, you can bring them in as a toolbar. So in order to do that, I'm just going to right click on empty space of my toolbar, and I'm going to find my solid tools, which are these guys over here. I'm going to dock them back up here. And you have several solid tools. You have outer shell, you have intersect, union, subtract, trim, and split. Now, some of these ones can be done with only two geometries at a time. So one object versus another object. Some of them you can use them with as many geometries at the same time as you want. So you could have 10 things selected. It doesn't matter. So that's thing number one. Thing number two is, I'm going to be entirely honest with you. I have no idea what's the difference between outer shell and union. To me, they both do the same thing. Like, I understand that there has to be a difference between them, but so far I have not done any kind of exercise within the realm of interior design that has yielded a difference between union and outer shell. So if you have a good example to provide me, by all means, feel free to do so in the comments. So let's see what all of these guys do. And one easy way to understand is you can think about all of these solid tools as Venn diagrams. So basically you're always going to have circle 1, circle 2, and the stuff between them. And basically the different commands are going to do different things to the two circles and the space of intersection. So first of all, intersect. So what intersect is going to do is going to take two solids that are intersecting into each other, and it's going to leave only the part where they are intersecting, and it's going to get rid of the rest. So I'm going to come here, click, and there you go. So it's keeping only the part of the geometry where the sphere and the cube were intersecting. It's a little bit easier to understand if I turn on X-ray vision. So see, you can kind of see the volume in between them. And when I go intersect, that is what I am being left with. So that's first one, intersect. Second one is union or outer shell. So what this one is going to do is basically merge these two geometries and get rid of like the part where they intersect. So it's basically the opposite of intersect. So I'm going to go union, and there you go. See, it has created this outline and it has gotten rid of the stuff between them. Undo. Now, the third one is going to be subtract. Now, subtract is going to be the first one where you cannot just select both geometries and click subtract, because basically what's going to happen is that you can only have two objects. One of them is going to be the subtract, and the other one is going to be the subtractee. So like the one from where things are going to be subtracted. So in this case, you can go and click on subtract. And if you look on your bottom left corner on your cheat sheet, you're going to see that it's telling me to select my first solid. This is going to be the geometry that is subtracted. And then the second solid is going to be the geometry that it is subtracted from. So I'm going to click this guy and then this guy, and then see, I've subtracted the shape of the sphere out of the box. Pretty cool. And I can, again, go in the opposite direction. If I click first on the box and then on the sphere, then I am cutting a corner out of my sphere. So that's first. That is like a 1-2 step, the subtract. Then we have trim. So trim is going to be very similar to subtract, but it's not going to get rid of the subtract. So I can come here and say, okay, I want to carve out the sphere shape from the box, but I want to keep the sphere. So click and then click. I absolutely love this one, especially when you want to do something like, let's say, a custom vanity that is working with a very interesting vessel sink. Especially like I did this once where the vessel sink was like carved out of like a solid rock. So it was all jagged and ununiform. So I basically just put it on a wooden vanity top. And then I used this to carve the shape of that vanity stone out of the wooden base. So this is a pretty cool one. And then finally, you have a split, which is basically going to break your solids into 3 objects. You're going to have the cube minus the sphere shape. You're going to have the sphere minus the cube shape, and then the part where the Venn diagram intersects. So I'm going to select these 2. I'm going to go and split, and there you go. So see, now if I move this guy to the side, we have the sphere minus the box. We have the box minus the sphere, and we have their intersecting portions. So it's a really cool tool. I absolutely love solid tools. This is why, to me, it is worth it being a psycho about having clean geometry, because then I can make really cool interactions between complex 3D geometry. Now, before we wrap it up with solid tools, I just want to reiterate that you're only going to be able to use these tools if you are working with solid geometry. So for example, if I come back here and I make my box like before and I delete one of the faces, so it's not a solid, you're going to see I'm going to make it into a group and it's just going to tell me that it's a group. If I try to use any of my solid tools with this guy, I'm going to get an error message. It's going to tell me one or more of the selected objects is either not a solid or is locked. The non-solid objects will be deselected before this operation is performed. So it's telling me like, no, I cannot work with groups or components that are not solid. You also cannot use solid tools with raw geometry. Even if it's raw geometry, that would make a solid. So see, for example, if I come here and I fix this box, so see, now it's a solid, but I explode it, so it's raw geometry, and I try to use my tools, once again, it's going to tell me that it cannot do it because solids can only be groups or components, okay? So very important to understand. So, okay, let's say that you want to do some of these really, really cool intersections, but your geometry is not solid. You have been working on this model for 10 hours, and now you're realizing that it's not a solid, and it's going to be really, really hard for you to figure out where the issue is. So you're like, you know what? I just want to be able to like intersect these guys, but I don't want to have to convert them into solids. So what do we do then? Well, in these cases, you can use Intersect. So Intersect is basically solid tools with extra steps, and it's going to allow you to get the benefits from solid tools without having to have solid geometry. But again, it is going to take a little bit longer because it's not an automated process. So the way that Intersect Faces works is by forcing Sketchup to recognize faces that are intersecting with each other. Because by default, if we go back to the Sketchup system rules, points affect lines, lines affect faces, but faces do not affect other faces. So even if these would all be raw geometry, you would still not be able to get anything out of them because faces, when they crush into other faces, don't recognize each other. So that's where Intersect Faces comes in. So the way that we're going to use this tool is going to be the following. You can select all of the geometry that you want in this intersecting process, and you're going to right click on it. And if you go down the options, you are going to find Intersect Faces. And you're going to see there's actually 3 options. It's only showing me 2 for the time being because of the selection that I have. We have with model and we have with selection. First thing, never select with model. Because if you click on with a model, what Sketchup is going to do is basically read the entire model and figure out what geometry is interacting with what geometry. It's going to take 10,000 years and your computer may crash and burn in the process. So instead, what you always want to do is go with selection, or the third option, which we might later see, is with context. So in this case, I'm going to go with selection. And basically, see, it's thinking for a second, and there we go. So basically what Intersect with Faces does is recognize faces that are interacting with each other, and then it's creating lines in that connection that would cut those faces. Now, the way that I did it here is not the correct way, because basically what's happening is that the lines from the intersection are raw, and they're going to be outside of my groups. So basically, we're not really going to be able to edit any geometry. But just to show you what Intersect with Faces does, what I can do is now I can move this guy here, and I can move this guy here, and see, this is what Intersect with Faces does. It basically creates an outline where 2 faces intersect with each other. Okay, so now how would we use this tool for realsies? Well, this is going to depend on what is it that we want to do. So what I want to do is I want to walk through the different options that we have with solid tools, so you can see that we can do the same thing that we do with solid tools here. It's just, again, extra steps. So let's start with intersecting. So if we want to intersect, what you need to do is make sure that all geometry involved in this intersection is raw. So this is going to be the first scenario where it is okay and good to explode stuff. So I'm going to select my two geometries that I want intersected, and I'm going to go and explode both of them. So if you have geometry within geometry within geometry, you're going to explode until you have raw geometry. Okay, so before I go with my intersection, I'm going to turn on my X-ray vision so we can better see what's going on. Now, I'm going to first select all of my geometry, right click, intersect with faces, and we're going to go once again, selection. Bam. So see, once again, what Intersect Faces does is create outlines. But because we've created these outlines, basically now we have cut the faces of this geometry, and that is going to allow us to edit them separately. So for example, now I can go inside my box here and, for example, delete this face of my sphere and delete this corner of my box. And then when I'm done, I'm basically going to end up with exactly the same geometry that I had when I did my union/outer shell option. See, if I want to do the opposite, let's say that I want to do the intersection where we keep that intersected portion, it's the same thing, just in the opposite direction. I'm going to get rid of the leftover sphere and I'm going to get rid of the leftover box. See, so again, this is the tedious part. You're going to have to go segment by segment, but there you go. There is my intersected geometry. So now we're going to do the subtract option. So in order to do this guy, what we're going to do is we're once again going to start with exploding our geometry, and we're going to once again intersect our faces with selection. So what's going to happen here is that instead of deleting all of the inside intersecting faces or all of the outer left out faces, I'm just going to delete first the outer side of my sphere and then the corner of my cube. And there you go. There is your subtracted sphere from the box. And I could go in the other direction as well. Now, if we want to do something similar to what we do with the trim, this one is going to be a little bit more complex because basically you're just going to want to make a copy of whatever geometry it is that you want to leave behind, so to speak. So let's say that, again, I want to carve the shape of the sphere out of this box, but I want to keep the sphere. Well, you're just going to make a copy of the sphere before you move it away. Let's say that I'm going to move it 10 feet so I know where to return it. And then it's going to be exactly the same thing as before. I can just come here. I can just select both geometries. I'm going to explode them. I'm going to intersect the selection. And then I am going to delete the sphere, the corner, and then just group everything again so it doesn't, merge or anything, and bring this guy back 10 feet, right? So as you can see, you can basically do exactly the same things that you were doing with solid tools. It's just going to take a few extra steps. One thing that I do want to point out if you're going to be working with intersecting faces is to be careful with the explosion. Here, I'm just exploding into the model because there's no other geometry. But in practice, I would never just do that. What I would actually do is create a group or component that contains all of the things that I'm going to be intersecting, then go inside that group or component, and then within the safety of those boundaries, I would start exploding things however way I want. Because again, remember, the problem is that if you explode a geometry into its raw parts, and for whatever reason, any of those parts is touching raw geometry from somewhere else in the model, it's going to automatically become fused. And then you're going to have a bad time. And we don't want you to have a bad time. So just make sure that you set up things to minimize that kind of risk. And with that, we have reached the end of this video. I hope you find that helpful. If you did, give it a like, maybe subscribe. If you have any questions, by all means, feel free to add them in the comments. But otherwise, thank you very much for joining in. Thank you very much for sticking through, and I will see you in the next one. Bye!